Good morning, everyone. Good morning, everyone. Okay, today I'm going to start electrostatic chapter. Okay, now subtopics. I'm going to explain the subtopic. Yes. Okay. Now we will see. Okay. This is a NCERT problem. So this is a positive plate. Positive plate. This is a negative plate. Negative plate. Here, race between. Here I'm going to connect the running race. I'm going to connect the running race between proton and electron. Proton and electron. This is a proton. This is a electron. Proton electron. This is a proton. This is an electron. So both are moving from positive plate to negative plate. So which one will be win the running race? Which one will be running race? We know very well direction of electric field is from positive to negative. Positive to negative. This is a direction of electric. So we know so acceleration F is equal to E is equal to intensity of electric field is equal to force by charge. F is equal to EQ. F is equal to EQ. According to Newton's second law, F is equal to ma is equal to EQ. A is equal to EQ by M. EQ by M. You will see here. So A is equal to EQ by M. EQ by M. A means acceleration of the charged particle. That is positive charge may be negative. This is E means direction of electric field from positive to negative. Q means charge. M means mass of the charge. Maybe positive charge, maybe negative charge. Now this is E is constant for the both charges. E is a constant for both charges. So M is changes. Q also changes. A inversely proportional M. I'm going to write A inversely proportional 1 by M. I'm going to write. This is the mass of electron. This is the acceleration of electron. This is the mass of proton. This is the mass of the proton. This is acceleration of the proton. Acceleration of the proton. Do you know very well the mass of proton is greater than 2 mass of electron. Mass of proton greater than 2 mass of electron. Now we know mass of proton is greater than 2, mass of electron is less. What will happen? It is more means it is less. It is less means it is more. Now finally, result is AE greater than AP. This is now race will win. Who will win the race? Electron will in the race. Electron win the race. Electron win the race. You see, this is a positive plate. This is a negative plate. Direction of electric field from positive to negative. Positive to negative. So this is an electron. This is a proton. This is electron. This is a proton. Now This is a positive charge. This is a positive charge. This positive charge ripple to positive charge is downward direction. This positive plate attracts the negative charge is upward direction. Upward direction. Now you will see this is A is equal to EQ by M. EQ by M. So A is equal to EQ by M. A means acceleration. M means mass. E means direction of electric field. Q means charges. Q means charges. This is mass of the proton is greater than to mass of electron. Mass of the proton is greater means the acceleration of the proton is less. Mass of electron is less means acceleration of electron is more. Now electron win the race. Electron win the race. This is now second point. This is right. This is a positive plate, negative plate. Now you will see, and this is a proton and electron. Both are projected with a velocity v and perpendicular to the direction of electric field. This is a direction of electric field. This is a positive charge or negative charge. Both charges are projected with a v speed perpendicular to the electric field. Perpendicular to the electric field. Perpendicular to the electric field. This is the direction of electric field. This is the direction of electric field. This is a speed, v speed. You will see angle between here is 90 degrees. Angle between here 90 degrees. This is a proton or electron are projected with a v speed perpendicular to the electric field. Perpendicular to the electric field. Electric field. Which charge will be deviated more? Yeah. So here, this is a projected so v speed. So initial same speed both charges, same speed for initially same speed for positive charge, negative charge, positive charge, negative charge, same speed for both charges. Now you will see, we know S is equal to UT plus of AT square. So what is the meaning of this equation? Distance traveled by the electron or positive charge. Distance traveled by the positive charge or negative charge. In a t second. This equation indicates distance traveled by electron or proton in a t second. This equation. Now S means, what is the meaning of S? Distance. Distance means this is I'm taking y. I'm taking y. Now this positive charge, negative charge. You will see one thing. Suppose negative charge. Negative charge is projected in the direction of electric field means this is a positive plate. This is a negative plate. This positive plate will repel to the negative charges this direction. Suppose, for example, proton enter into the electric field. What will happen? This is projected along the x-axis means this is a negative plate. Negative plate will attract the positive charges this direction. This direction. Now you will take at this point after t second velocity of the charge particle is at this place Vx is equal to u, the uniform velocity. The particle is charge particle is moving along the x-axis means the charge particle is moving along the x-axis means the charge particle is moving in a uniform velocity. Now it is moving down means this is a freely falling initial velocity uy is equal to 0. This is a vy. In y-axis, this is a freely falling body. Freely falling body we are saying. Freely falling body. This is a velocity of the charge particle. This is a velocity of the charge particle. Velocity of charge particle. What particle? Positive charge. This can be divided into two components. One is Vx, another one is Vy. This is a velocity of charge particle. Velocity of the charge particle at this place at t second. After t time, final velocity of the charge particle at this place. This can be divided into two components. One is Vx, another one is Vy. This charge particle is moving with uniform velocity. This charge particle is freely falling body in y-axis. In y-axis, freely falling body. The charge particle moving along the x-axis means uniform velocity. The charge particle moving along x-axis means the charge particle is moving with a uniform velocity. Uniform velocity. Now you can take sy means I'm taking and y-axis in a distance is s means distance. Y means distance in a y-axis, and the charge particle moves in a vertically downward direction. I'm taking y. Next to uy. So what is the in y-axis? What is the position of this point? Freely falling body. Now velocity is 0 plus of a means eq by m t square. T square means time. Velocity is equal to distance by time. Now I'm taking, so T is equal to, I'm going to write L by V. L by V. Now, so y is equal to, I'm getting 1 by 2 e cube by m t square. T square. Now 1 by 2 e cube by m. T means L by V whole square. Now you will see 1 by 2 e cube by m L squared by V squared. This is y. This is equation 1. Now initially positive charge and negative charge both having the same speed. Both having same speed. Same speed means the speed also constant. This is the length of the plate. Length of the plate. Length of the plate also constant. And the electric field is constant. Electric field is constant. Q also constant. 1 by 2 is constant. Remaining y inversely proportional 1 by m. This is. Now y inversely proportional 1 by m and y inversely proportional 1 by m. This is a electron, this is electron, this is a proton, this is proton. Now we will see mass of the proton is greater than 2 mass of electron. Mass of the proton is greater than 2 mass of electron. This is more, this is a less, this is a less, this is a more, and y greater than and y. And so y means distance. Y means distance. And which charge will more deviate? Which charge will be more deviate? And negative charge will deviate more. Negative charge will deviate more. Negative charge will deviate more. That is the meaning of that. My question is, in this point, positive charge and negative charge both are projected perpendicular to the electric field. Positive charge, negative charge are projected perpendicular to the field. Which charge will be more deviate? My question. Which charge will be more deviate? Condition is initially both charges having same speed. Condition number 1, positive charge and negative charge both charges having same speed. But my question is, negative charge will travel more distance or positive charge will travel more distance? Which charge will be travel more distance? Which charge will be more deviated? This is we call deviation. We call deviation. Which one will more deviation? Which charge gets more deviation? Electron will get the more deviation. That is the answer is electron gets more deviation by the electric field. And positive charge gets less deviation by the electric field. What is the reason means? This is explanation. That is the explanation. Next. Next, same momentum. Initially, same momentum. Now you can take y is equal of e cube by m t square. So y is equal to of e cube by m t square. Now t square means L square by p square. Now this equation converts to momentum. So y is equal to 1 by 2 eq L squared by mv squared. I am dividing m by m. Now, so y is equal to 1 by 2 eq L squared by m into m squared into v whole squared. I am writing this. Do you know very well momentum means p is equal to product of mass into velocity. Now y is equal to 1 by 2 eq L squared m by, so this is a momentum, this is a p square. I'm going to write it. This is, I'm getting the equation. Y is equal to 1 by 2 eq L squared m by p square. Now same momentum, positive charge and negative charge both having same momentum. Positive charge and negative charge both having the same momentum. Same momentum means constant. Momentum is constant for the both charges, and length of the metal rod, I mean positive charge and negative charge, the length of the rod constant, and this is the electric field also constant, and the q also constant. Now 1 by 2 is constant, y directly proportional m. So y directly proportional m means this is the electron, mass of electron, proton of the proton displacement, this is proton mass. Do you know very well mass of electron is less? We know very well mass of proton greater than to mass of electron. We know this condition. Mass of electron is less, displacement of charge particle is also less. This is the mass of the proton. Mass of the proton is more means displacement of the particle is also more. Now conclusion is yp greater than ye in this situation. When it is possible situation, same momentum. Initially both charges having same momentum means yp greater than ye. Same speed means before I explain. Now same kinetic energy. Next condition is same kinetic energy. Same kinetic energy. Now next case, same kinetic energy. Same kinetic energy means y is equal to 1 by 2 eq by m L squared by v squared. eq by m v squared. Now same kinetic energy means so y is equal to 1 by 2 eq L squared by, this is a m squared. Now same kinetic energy means this equation turns to the kinetic energy. How does it turn kinetic energy? Kinetic energy means of m squared. This is a general formula. We know m squared, but there is no half. I'm taking this is 1 by 2 into 2. This is 2 into 2. Now 1 by 2. This is I'm going to write this is half m squared means kinetic energy 2 into 2 4. Now so y is equal to eq L squared by half m squared means kinetic energy 2 into 2 4. This is our equation. Y is equal to eq L squared by kinetic energy 4. In this equation you will see, and both charges having the same kinetic energy. Positive charge and negative charge having same kinetic energy. Kinetic energy is constant. Next, the length of the plate is for positive charge, negative charge is constant. Next, direction of electric field is constant. Charge is also constant. 4 is constant. Y is equal to constant in this. So yp is equal to y. This is the meaning. This same kinetic energy means both displacement are equal. Displacement of proton is equal to displacement of electron. అంటే రెండు charges same distance travel చేస్తాయి. ఇది 5 మీటర్లు ట్రావెల్ చేస్తే ఎలక్ట్రాన్ కూడా 5 మీటర్లు ట్రావెల్ చేస్తుంది. ఎప్పుడు బోత్ చార్జెస్ హ్యావింగ్ ద సేమ్ కైనెటిక్ ఎనర్జీ. ప్రోటాన్ కి కైనెటిక్ ఎనర్జీ సేమే ఉండాలి, ఎలక్ట్రాన్ కి సేమ్ కైనెటిక్ ఎనర్జీ కింద ఉంటే రెండు చార్జెస్ కూడా సేమ్ డిస్టెన్స్ ట్రావెల్ చేస్తాయి. బోత్ చార్జెస్ విల్ సేమ్ డిస్టెన్స్ both charges are travel same distance when both charges having the same kinetic energy. This is the now conclusion. So what is the conclusion? You will see. Now conclusion. Same speed means same speed. Once again I am explaining same speed. So y is equal to 1 by 2 eq m by l square v square. Same speed means all are constant. So same speed means y directly proportional to m, proton, electron. So we know condition. This is we know this very well. More, less means more. In this situation, y greater than yp. In this situation, this is the same speed. Now, same momentum. Same momentum means initially same momentum means y is equal to half eq by mp whole square l square by m. Now how can you get to this? Is I'm showing once again. This is m l square v square m by m. I'm dividing. So y is equal to 1 by 2 eq l square m into m square mv square. This is the momentum. This is so you can write this is directly moment square. Now in this equation, this is constant, this else constant, all constant. But so y directly proportional m. Y directly proportional m. So y directly proportional m means we know condition greater than this is condition. Now this is a mass, proton, electron. Mass is more means this displacement also more displacement. This is less means this also less. Now we will see what will happen in this situation. In this situation, more masses, more, less. Now, which one is conclusion here? Displacement of particle is proton is more in this situation. Now, last situation, same kinetic energy. Same kinetic energy is equal to 1 by 2 eq l square by m square by 2 into 2 by 2 into 2. Now your equation is y is equal to kq l square by 4 kinetic energy. This all are constant. K constant to this is eq most. Intensity of electric will constant, q constant, l square constant, 4 constant, everything is constant. Y is equal constant. Y is equal to constant means displacement of charge particle is equal to displacement of electron. Both are equal in this situation. That is conclusion. Same speed means displacement of electron is greater than to displacement of proton. Same momentum means displacement of proton is greater than to displacement of electron. Same kinetic energy means displacement of proton is equal to displacement of electron. That is a conclusion. Now next. This is a NCERT problem. I explain this problem is, this is the NCERT problem. Now next concept is dipole, electric dipole. Next concept is dipole. Dipole. So dipole. So this is a electric dipole. This is very important. So very important. Electric dipole means this is, I'm taking, this is a Q charge. This is a Q. This is a one more charge. Both charges are equal. And this is a, for example, 5 coulomb. This also 5 coulomb. 5 coulomb. And both charges are equal. Both charges are equal magnitude. Equal magnitude. Now this is a negative. This is a positive. Opposite charges. Negative charge, positive charge. Both are opposite charges. Equal charges, opposite charges. Equal charges, opposite signs. Separated by a small distance. Separated by a small distance, that is a 2a. That is a 2a. This represent is called as a dipole. Dipole means di means two mass. So di means two poles. Di means two poles. This is a negative charge. This is a positive charge. This is a equal and opposite charges. Equal and opposite charges separated by a small distance between two charges is called as dipole. Is called as dipole. So once again, this is a negative charge. This is a positive charge. Negative charge, positive charge. Equal charges, opposite charges. Equal and opposite charges are separated by a small distance is called as electric dipole. Electric dipole. Now we will see the next dipole moment. Dipole moment. Dipole moment. Dipole moment. So dipole moment means literally this is a negative charge. Negative charge. This is a positive charge. Equal and opposite charges separated by distance. Separated by a distance. Separated by distance is a 2a. And this is we call this is the center of dipole. Center of dipole. We call this is center of dipole. This is a center of dipole. From here to here is a distance a. From here to here is a distance a. Next, dipole momentum. Letter is P mark. P indicates dipole momentum. Direction of dipole momentum is from negative to positive. This is a dipole momentum direction. P indicates dipole momentum. Direction of dipole momentum is from negative to positive. Negative to positive. This is a dipole momentum. So what is the definition of dipole momentum? Means dipole momentum P bar is equal to Q. This is a dipole momentum. You can take a P bar is equal to product of magnitude of any charge, maybe negative charge, maybe positive charge. This is a product of any charge, magnitude of any charge, positive charge, maybe negative charge, into distance between the two charges is called as dipole momentum. Dipole momentum. Dipole momentum. It is very important. So once again, I explain dipole momentum. Dipole momentum means this is a magnitude of charge, maybe positive, maybe negative. You can take positive or negative, any charge. Magnitude of any charge, maybe positive, maybe negative. This is a 2a. Distance between two charges. This is a 2a. Distance between two charges. This is a dipole momentum. P bar is a dipole momentum. That is a dipole. Now it is a vector quantity. Vector. It is a vector. SI unit is SI unit of dipole. Dipole momentum is SI unit is this is a Q means SI unit of Q is coulomb. This is a 2A. Distance between the two charges is a meter. Coulomb meter. Coulomb meter. Dimensional formula of P. Dimensional formula. So next Q means this is a Q means we know Q is equal to current is equal to Q by T. Q is equal to IT. I means A, T means AT. AT into meter. AT into meter. And meter means length. We are checking. That is the dimensional from formula of dipole momentum. Dimensional formula of dipole momentum. Now there is a dipole momentum. Dipole momentum dimensional formula. Dimensional formula. Now we will see. So what is the net charge of the dipole? Net charge. Net charge of dipole momentum. Dipole is negative charge plus positive charge. Net charge is 0. Q net is equal to net charge of dipole is equal to minus Q plus Q, 0 charge. 0 charge. But electric field is electric field is not equal to 0. Not equal to 0. Equal to 0. Not equal to 0. Electric field is not equal to 0. Electric field is not equal to 0. Electric field is not equal to 0. Now dipole means two poles. Negative charge, positive charge. Equal and opposite charges are separated by a distance. Equal and opposite charges are separated by a small distance. It's called as dipole. Dipole momentum means negative charge and positive charge. Negative charge and positive charge. This is a line. This is center of dipole. And from this point to origin point is A and A. So distance between the two charges is 2A. Definition of dipole momentum. P bar indicates dipole momentum is equal to Q into 2A. It is a vector quantity. It is a SI unit of dipole momentum is Coulomb's meter, and dimensional formula of dipole momentum is ATL. Net charge of dipole momentum is 0. Electric field is not equal to 0. Direction of dipole momentum is direction of dipole momentum is dipole moment is from negative charge to positive charge. Negative charge to positive charge. Negative charge to positive charge. Next, ideal dipole. Ideal dipole means so Q becomes infinity. 2A becomes 0 because this is an ideal dipole. Ideal dipole we are called. Ideal dipole. Now next one is this is a dipole. Dipole means two equal and opposite charges are separated by distance 2A is called as dipole. Dipole momentum means product of any charge, negative charge, maybe positive charge. Magnitude of any charge into distance between the two charges is called as dipole momentum. It is a vector. It is a dipole momentum is a Coulomb meter. A dimensional formula of P is equal to ATL. Net charge of the dipole is 0. Electric field is not equal to 0. E is not equal to 0. Direction of dipole momentum is always from negative to positive direction. Ideal dipole is Q is infinity. 2A is equal to 0. Next, I'm going to explain axial line and equilateral line. axial line, axial line, axial line. So what is the meaning of axial line? The axial line means this is a negative charge, this is a positive charge, this is a line, this is center of dipole. Distance between two charges is from here to here is A, from here to here is A. This is the distance between the two charges is 2A. Now, one straight line passes through negative charge through origin and positive charge. This line we call axial line. This line we call axial line. Axial line. One straight line passes through negative charge to positive charge. This line is called as axial line. Axial line. Next to one more line, axial line. We call this is axial line. This line we call axial line. Axial line. Next to equatorial line. Equatorial line. Equatorial line. Equatorial line. Equatorial line. So equatorial line means you see that this is a negative charge. This is a positive charge. So this is center of dipole. Center of dipole O. From here to here is A. From here to here is A. Distance between the two charges is 2A. Distance between the two charges is 2A. Now, one straight line is passes through center of dipole. This line is perpendicular to the axial line. Straight line. This is a straight line. This straight line is passes through center of dipole. Center of dipole. This line is called as equatorial line. Equatorial line is perpendicular to the axial line. Perpendicular to the axial line. Because this line is equatorial line. Equatorial line. One straight line. Equatorial line means what is the meaning of equatorial line means? Straight line passes through center of dipole. This straight line is perpendicular to the axial line. This straight line is called as equatorial line. Equatorial line. Direction of dipole momentum is from always. Direction of dipole momentum is always direction of electric dipole momentum is from negative to positive. Here also negative to positive. Negative and positive. This is the direction of dipole momentum. This is axial line. That is a equatorial line. Axial line, equatorial. Axial line means axial line. Direction of electric field, direction of dipole momentum is from negative to positive. Negative to positive. Direction of dipole momentum is from negative to positive. And one straight line is passes through negative charge to positive charge. This straight line is called as axial line. One more straight line is passes through center of dipole. This straight line is perpendicular to the axial line. This line is called as equatorial line. Equatorial line. Equatorial line. Next derivation. I'm going to explain that. This is a very, very important for IP and competitive. Next concept. Intensity of electric field. Intensity of electric field. Field due to axial line. Axial line. Intensity of electric field due to axial. This is a IP question. This is IP 4 marks question. Intermediate 4 marks question. It is very, very, very important. Very, very important. Now you will see what will happen. Now I'm checking first. We have to calculate intensity of electric field due to axial line. Axial line. Okay, you see, this is a negative charge. Negative charge. This is a positive charge. This is we call center of dipole. Center of dipole. Now once straight line is passes through, once straight line is passes through negative charge to positive charge, this line we call axial line. We call this is a axial line. Axial line. This is the axial line. This is axial line. Now I'm placing at this point Q0 test charge. This is a Q0 test charge is placing at this point. Now this is I'm checking. Okay, from here to here is this is a test charge. Test charge keeps on axial line. This is a center of dipole. Distance between here to here is R. Distance between center of dipole to and point test charge is R. Now distance between here to here is from here to here is A. From here to here is A. This is a dipole moment. Distance between the two charges is totally 2A. 2A. Distance between the two charges is 2A. Now you will see this is a negative charge. This is a negative charge. This negative charge, this is a positive. This negative charge will attract negative charge this direction. This is I'm taking E1. At this point, I'm calculating E1 is equal to. At this point, we have to calculate E1 due to the charge. KQ by distance between from here to here. What is the distance between here to here? Here to here is R. Here to here is A. This is R plus A. R plus A. Now E1 is KQ by, this is a minus Q. Minus Q is taken as positive charge when I'm calculating resultant intensity of electric field at this is a P point. At this P point. Now this is E1. Direction of electric field is towards charge, towards negative charge. Direction of electric field towards the negative. Now distance between the two charges is R plus A. This is R plus A whole square. This is equation number 1. Direction of electric field is towards, this is a A point, this is a B point. Direction of electric field is direction of electric field is direction of electric field is PB, PA direction. PA direction. This is E1. Next, this is a positive charge. This is a positive charge. This positive charge will repel to this positive charge is this direction. That is, I'm taking E2. E2 is equal to, B2 is equal to. Now charges are here. This is a distance between the two charges. This is the distance between the two charges. I want this distance. This is the distance I want. From here to here is R. From here to here is R. From here to here is A. I want this distance means R minus A. R minus A. I want this distance. At this point, we have to calculate E2 due to this charge. KQ. Distance between the two charges is R minus A whole square. Direction of electric field is direction of electric field is from this is this direction BP. This is a direction BP. Direction of electric field is BP. Now at P point, resultant electric field I want. Resultant electric field is equal. Which one is greater? Which one is lesser? We have to calculate the resultant electric field at the P point. Now which one is greater? Which one is lesser? R plus A is greater. R plus A is greater. This is R minus A. R minus A whole square. R plus A greater than 2 R minus A. Now you can take this is greater. So this is greater means this is a lesser. This is a lesser distance means more electric field. More electric field. Now resultant intensity of electric field at the P point is equal. So E2 greater than E1. E2 greater than E1. Now E2 greater than E1. So what is the reason? Means this is the reason. Distance between the two charges. Now next, so we are going to E2 means E2. E2 means what will happen? E2 means I will see. So final conclusion is so we are going to solve the ER is equal to E2 minus E1. E2 minus E1. So what is the reason? What is the reason? Reason means R plus A whole square greater than R minus A whole square. That's why E2 minus E2 greater than E1. E2 greater than E1. Now you will see ER is equal to E2 means KQ by R minus A whole square. KQ by E1 means R plus A whole square. Now take the LCM. ER is equal to take LCM. R minus A. This is A square. This is a B square. A square minus B square. R square. Take common KQ. KQ common. So what will happen? This is R plus A whole square minus R minus A whole square. Now ER is equal to KQ by this is A minus B whole square. This is A plus B whole square. We know. So what will happen in this situation? A minus B whole square into A plus B whole square means this is the A square minus B square and whole square. Now we'll take. Now this is I'm taking R square minus A square and whole square due to this way. A minus B whole square into A plus B whole square means is equal to A square minus B square whole square. I'm going to write. Now this is you see this is A plus B whole square. R square plus A square plus 2 RA next minus this is R minus A whole square. R square plus B R square plus A square minus 2 RA. Now simplify this one. R square plus A square plus 2 RA minus take inside R square minus A square plus 2 RA. Minus R square plus R square A square plus minus A square, finally 4 RA. Finally, this entire result is 4 RA. 4 RA. 4 RA. That is A plus B whole square minus A minus B whole square expansion. Final result is 4 RA. So now resultant intensity of electric field is KQ. This is I'm going to write to this is okay. Now here R square minus A square whole square. This is a KQ. K. This is a Q. This is a 4. I'm writing 2 into 2. This is a A. This thing. Now is K. This is K. Q. Here Q. 2 into 2 4A. Now this is R. This is a R. I'm writing. This is a 4A R Q K. This is I'm writing 2A Q R K 2. This is do you know very well? This is ER is equal to, this is I'm writing K. This is 2Q into Q into 2A. I'm writing. This is we call dipole momentum. Dipole momentum. This is R2. Now this is I'm going to you see A R is much greater than A. Much greater than A. A should be neglected. Small value is neglected. This is R square and whole square. A square is neglecting. So finally ER is equal to KP R into 2 by R power of 4. R cancel. Now ER is equal to 2 KP by R power of 3. R power of 3. That is a your answer. R power of 3. Now, so finally, you will see direction of dipole momentum is from negative to positive. This is the direction of dipole. Result in the electric field ER, which direction? Direction of electric field is which direction? Which one is greater? E2 minus E1. E2 means this is a resultant electric field. Resultant electric field direction. Now we will see direction of This is a resultant of electric field direction along E2 direction and direction of dipole momentum. Both are same direction. Both are same direction. P bar parallel to E or resultant. Theta is angle between the two is 0 degrees. Angle between the two is 0 degrees. Now that is your answer. That is your answer. This is a very, very important and so your IP. Your IP. Once again, I'm going to explain the. This is the intensity of electric field due to axial line. Now you will see once again. I'm going to explain the diagram. Excellent. This is a negative charge. This is a negative charge. This is a positive charge. This is a line. We are calling line. This is a test charge. Because this is axial line. Axial line. This is we call axial. Distance between two charges is this is a 2a. This is a point of dipole. From here to here is a distance a. This is a from here to here is distance is a. This is a dipole momentum. Direction of dipole momentum is from negative to positive. Now this is a dipole momentum. This is a center of dipole. This is a test charge. Distance between and center of dipole and test charge is R. This is you take P. This is a A point. This is a B point. This is a P point. That is it. Now we will see. This is a negative charge. This negative charge, the charge attracted in this direction. That is the direction of electric field. This is E1. And distance between the two charges is from here to here is here to here is R, from here to here is R plus A. At this point, this is a point charge. We have to calculate intensity of electric field at this point due to the charge. Negative charge is taken as positive charge. K cube by distance between the two charges R plus A whole square. Direction of electric field is from P to A. That is the first part. Next, this is a positive charge. This positive charge will repel to this positive charge in this direction. That is the electric field E2. This is a charge. Distance between the two charges. This is I1. From here to here is R. From here to here is A. This is a capital R. This is a R. This is A. I want this distance R minus A. At this point, we have to calculate E2 due to the charge. K cube by distance between the two charges R minus A whole square. Direction of electric field is this is a positive charge. Direction of electric field is always away from the charge. That is BP. Direction of electric field is BP. Now at this point, at this P point, we have one is the direction of electric field is one is this direction, another one is this direction. We have the two direction of electric field at this point. Which one is greater? Which one is lesser? R plus A is greater. R minus A is lesser. This is a more distance. This is a less distance. More distance means less electric field. Lesser distance means more electric field. Now E2 minus E1. We are going to simplify this equation. Finally, we are getting direction of resultant intensity of electric field at axial point is equal to 2 kp by r cube. 2 kp by r cube. Now I'm going to write it. This is 2p 1 by 4 pi epsilon r r power of 3. R power of 3. Okay. Thank you, ma. So the class is forward. Tomorrow I will continue the next topic. Thank you.